Hello students, this is a topic test that we bring you to help you understand your level of preparation. Once you have gone through the basic concepts of any topic, we are advised to pick up these tests and attempt these tests in a timed manner so that you're able to understand what concepts you're able to actually apply in an exam. Once you have given the test, then comes the video where we try to give you a perspective of what would have been a good attempt, which questions should have been looked at, what could be a good time, what was the level of difficulty, so things like that. And yeah, if you do like the tests and the videos, there are more than 200 topic tests available on the Bodhee Prep Android app. The link for the app is in the description. Just download the app and start making use of these tests, which we have prepared for you. This video is about the topic time and work, specifically about test 3, as is mentioned in the app. Overall, this test was again a moderate level of difficulty test. A good attempt would have been 6 questions, and the attempt time for this test would be about 21 to 24 minutes. 6 questions, net correct, would ensure that you end up getting a 95 odd percentile for the test. Now, if you look at the questions here, second, yes. The cost of the feed for 30 cows and 40 buffaloes is 20 for 20 days is 3,400 rupees. The cost of feed for 20 cows for 40 days is 2,400. Therefore, can I not say 20 cows for 20 days will be half of this, that is 1,200. And therefore, 10 cows for 20 days will be half of this, that is 600. And therefore, 30 cows for 20 days will be 3 times of this, that is 1,800. So first I halved the number of days, so the value became half. Half the number of cows, the values became half. Became half. The number of cows was made 3 times, so the value became 3 times. So if we look at this, 30 cows plus 40 buffaloes for 20 days costing 3,400 rupees. 1,800 is for 30 cows. Therefore, we can say 40 buffaloes for 20 days will cost 34 minus 1,800, 1,600 rupees. Next, find the cost to feed 40 cows and 20 buffaloes for 10 days. 40 buffaloes for 20 days is 1,600. 40 cows for 10 days. Okay. 40 buffaloes for 20 days is 1,600. So 40 buffaloes for 10 days will be half of this, that is 800. And therefore 20 buffaloes for 10 days will be half of 800, that is 400. We have 20 buffaloes for 10 days. Here we had 40 cows for 20 days. 40 cows. So if we work with this, 2 to the 4, 4 to the 10, or rather, just work with this. 20 cows for 20 days. So we double the cows, 40 cows, and half the time for 10 days will require the same amount, that is 1,200 rupees, because the number of days becomes half, so the cost will become half. The number of cows double, so the cost will again double. So 20 cows 20 days, that is 40 cow days, and 40 cow 10 days is the same, so the price should be same. So if we add these two now, 40 cows and 20 buffaloes for 10 days will cost 1,200 plus 400, which is 1,600 rupees, which becomes my answer. Again, equations can become a little confusing. We get into solving the equation, and I think that ends up eating a more time. So it's a moderate level of difficulty, and the attempt time can go up to 120 seconds. ABC can finish a job working alone in 15, 20, 25 days respectively. However, while working with somebody, efficiency of ABC reduces by 30, 20, and 50% respectively. If none of them is allowed to work for 3 consecutive days, what is the maximum possible fraction of the job that can be completed in 4 days? Okay, let the work be 15, 20, and 25. 75, 100, 60. 25 into 4, 100 into 3, 300 units. And therefore efficiency of Aman working alone will be 300 upon 15, which will be 20 units. Efficiency of Aman will be 300 upon 20, that is 15 units per day working alone. For C, it will be 300 upon 25, which will be 12 units per day. But when they're working with somebody, the efficiency reduces. 30% of 20 is 6. So the reduced efficiency will be 14 units per day. Here, reduction is 20%. 20% of 15 is 3. So the reduced efficiency will be 15 minus 3, 12 units per day. And for C, the reduction is 50%. So Chaman's efficiency from 12 units will go down to half. That is 6 units per day when he's working with someone. Now, in 4 days, we have to maximize the work. So what we can do is day 1, day 2, day 3, day 4. So on day 1, we can make ABC all the 3 work together to maximize work. Similarly, on day 4, we can make all the 3 work together. So the 3 working together will do 14 plus 6, 20 plus 12, 32 units in on day 1, 32 units on day 2. 32. Next, what we can do is 35, 38. Next, what we can do is we can, on one of the days, make one person work, and on the other day, make 2 people work, so that no one is working for more than 2 consecutive days. If we make A work alone, A will do 20 units, B and C together will do 18 units, 6 plus 12. If we make B work alone, B will do 15. A and C will do 20 units, 35. If we make C work alone, 12 and 26. So this will also be 38. So what we can do is we can say on day 2, A works alone. On day 3, B and C work together. Or we could also have C working alone. And then here A and B working together. In both cases, here the amount of work will be 20 because when A works alone, we'll do 20 units. B and C working alone together, we'll do the reduced efficiency, that is 18. So 38 units gets done. If C is working alone, C will do normal efficiency, it is 12. A and B will work on reduced efficiency, which is 14 plus 12, 26. So again, 38 units of work gets done. So the maximum amount of work that can get done is 32 plus 32 plus 38 out of a total of 300. This becomes 236, 60, 70, 102 by 300. So divide by 6, this will give us 50. 6 ones are 6, 4 to 6. 17 by 50 becomes the answer, option B. Now, in terms of level of difficulty, I would say this is maybe moderate to difficult because when we add, it is very easy to forget the fact that when they're working alone, they're working at their normal efficiencies, and that can create a lot of confusion. But once that has been spotted, the attempt can go higher. Or, oh, sorry, the attempt can happen and the time will be lesser. But in any case, 2.5 minutes to solve. But because confusion can happen, I'm saying moderate to difficult question. On a certain day, Ajay works at 11th by 7th of his usual rate of doing work, completes the work 28 minutes earlier. Now, suppose the usual rate was A units per minute. The person is working at 11 by 7, A units per minute. And therefore, if the time usually works 11 by 11 seventh of his usual rate, if the time taken to do the work was t minutes, now the time taken to do the work will be 7 by 11 t because efficiency and time are inversely related. So we can say t minus 7 upon 11 t. This is how faster the work will get finished. That is 28 minutes. So 4t by 11 is 28. 4 sevens. So the total time usually required to do the work is 77 minutes. T. Now He's doing it in 28 minutes lesser, which is 49 minutes. Had Ajay worked at 11/7 of his usual rate. So instead of 8, if he had worked at 7/11 of his usual rate, 7/8 units per minute, normal time was T. Now the time taken will be 11/70. Then the time taken by him to complete the work would have been how much more than the usual time. So the extra time would have been 11/70 minus T, which would be 4/70. The value of T we have calculated as 77. So 4/7 into 77, which is 44 minutes. So the extra time required at this rate will be 44 minutes, option A. Again, easy to model sort of a question. Basic proportionality, we'll be able to solve this question. Should not take more than maybe 1.5 to maybe maximum 2 minutes. If there are 5 more men in a workforce, they will take 16 days less to complete the job. Suppose there are X number of men doing a work in Y number of days. Therefore, we can say that the total work is X into Y, number of men, number of days. If there were 5 more men, so the number of men was X plus 5, they would have taken 16 days less. So time taken would be Y minus 16, but the work will remain same. So we can say total work XY is equal to X plus Y into Y minus 6. This gives us XY is equal to, opening the brackets, XY plus 5Y minus 16X, 5Y minus 16X minus 80. XY cancel, therefore 0 is equal to 5Y minus 16X minus 80. This becomes equation number 1. Instead, if there were 12 more men, so instead of X, if there were X plus 12 men, and they would have taken 30 days less. So Y minus 30 is the time they would have taken. This is the total work, so should be equal to X into Y. Find the ratio of number of men and the time taken to complete the given work. We have to find the ratio of X and Y. And that is all we have to find out. We are not required to find values. If we open the brackets here, XY will be XY plus 12Y minus 30X minus 360. XY cancel. 12Y minus 30X is minus 360. This is equation 2. Now we have two equations in X and Y, so we can solve them to get the answer. Or since we are just looking to find the ratio between X and Y, what we do is we make the constant term equal. So multiply this by 9, 9 is 72. 0 will be equal to 45y minus 144x multiplied by 9. 144x minus 720. Multiply this by 2, 024y minus 60x minus 720. Let us call this equation 3 and this equation 4. We do equation 3 minus equation 4. So 0 remains 0. 45 minus 24 becomes 21y. 144 plus 60 becomes 84x. 720, 720, 0. So 0 is equal to 21y minus 84x, which means 84x is equal to 21y, or x by y is equal to 1 by 4. Option C becomes the answer. We can calculate the value of x and y and then also get the ratio, but that will only increase our attempt time. So rather than that, work with x and y, get the answer, and about 2.5 minutes to solve. Similar questions you probably would have attempted in time, speed, distance, where the speed increases and time decreases, and we have to find out distance and speed. So that can be, idea being, would have seen similar questions earlier, but overall, therefore I'm saying moderate level, not high level of difficulty, because would have seen this question earlier or similar question earlier. 10 pipes working at full efficiency can fill a tank in 30 hours. 5 pipes start filling the tank. The pipes work exactly for 40 minutes in every odd hour, 1/3, etc. And they work for exactly 50 minutes in every even hour. That is second, fourth, etc. If 7 more pipes working in the same manner as the existing 5 are added after 12 hours, then in which hour will the tank be full? 6, 4. So let the efficiency of one pipe efficiency of each pipe be 6 liters per hour. We can say that the capacity of the tank is 10 pipes filling 6 liters per hour for 30 hours. So 1800 liters. Now what happens is R1, there are 5 pipes which are working for 40 minutes. If a pipe fills 60 minutes, it fills 6 liters. That means in 10 minutes it will fill 1 liter. Therefore, in 40 minutes it will fill 4 liters, and 50 minutes it will fill 5 liters. Basic unitary method: divide by 6, multiply by 4, multiply by 5. So the first in R1, the 5 pipes will fill 4 liters per minute, that is 20 liters per hour. In hour 2, they will fill the 5 pipes will fill 5 liters per minute, that is 25 liters per hour. Therefore, in 2 hours, 45 liters gets filled. This happens for 12 hours. So we multiply this by 6. In 12 hours, 6, 20, 240 and 30, 270 liters has been filled. Beyond this point is if 7 more pipes work in the same manner are added. So after this, what happens is 13th hour, there will be 7 more pipes, 12 pipes working at 4 liters per hour. That is 48 liters will be added. In the 14th hour, we will have 12 pipes working at 5. So 60 liters will be added. So in 2 hours now, 108 liters will be added. Now suppose this process happens for X number of times, I can say 270 plus 108x should be less than equal to 1800. So we want to go to as close to 1800 as possible. So 108x is, let us just solve for equal to and see what happens. 180 minus 1800 minus 270, which will be 16, 15, 30, 15, 30, 108 divided by 1530 divided by 108. Okay. 1080, 108, 1530. This will give us 108, 450, 14. This, okay. So this will be 432. So what I'm saying is X can repeat 14 times. If this happens for 14 times, 432, 18 liters will remain. So therefore, in the first 12 hours, 270 liters gets filled. In the next 28 hours, this cycle being repeated 14 times, the amount of water that gets filled is 108 into 14, which comes out to 1512 liters. So in 40 hours, 1782 liters has been filled. In the next hour, 18 liters will get filled because in the next hour, 48 liters can get filled. So in the 41st hour, we will reach the position where 1800 liters has been filled, and therefore in this manner, it will take 41 hours to fill. In terms of level of difficulty, I would say it's a moderate sort of a question because the calculation involved is a little lengthy. 2.5 odd minutes to solve the question, provided a mistake does not happen. The work done by 2 men in a day is equal to the work done by 3 children in a day. The work done by 3 men in a day is equal to the work done by 5 women in a day. Let the amount of work done by a man in a day be M, that by a child be C, and that by a woman be W in this question. Therefore, 2M is equal to 3C. 2 men, 3 children, work done is same. And 3 men is the same as 5 women. So if we take M as 15 units per day, here we can see 2 into 15 is equal to 3C. 30 upon 3, C comes out to 10 units per day. And 3 into 15 is equal to 5 women. 3 into 3m, 45. W comes out to 45 by 9. So 9 units per day. This is the work done by each of them individually. If it takes 10 days for a man, woman, and a child to complete the work. So the total work that they are doing is 10 days. The amount of work done will be 15 units per day by a man, 10 by a child, 9 by a woman. Therefore, total work, this is per day work into 10 days is required, or they work for 10 days. So 15 plus 10, 25 plus 9, 34 into 340 units of work is the total work that has been done in 10 days. How many days will two children working together take to complete the work? Now, two children will do 10 into 2, 20 units per day. They are supposed to finish 340 units of work. Therefore, number of days required will be 340 work to be done at 20 units per day. 17 days becomes the answer, option C. Again, I think easy to moderate sort of a question. Should not take more than about 2 odd minutes to solve. Could be done in the exam also. If 4 men and 2 women can do a work in 48 days, while 2 men and 4 women can do the same work in 64. So if we let the work be 48, 64, 16 3 are 16 4s are 64 into 3, 64 into 3 units, and a man does m units per day, a woman does w units per day. We can say 4 men will do 4m, 2 women will do 2w units, and this is how they can finish off the total work 64 into 3 units in 48 days. So this will give us the efficiency of 4 men and 2 women to be 4 units per day. 16 4s are 16 3s are 3 3 cancel, and therefore 4m plus 2w is equal to 4. Similarly, 2 men and 4 women working finish of the work in 64 days. So their efficiency will be 64 into 3 by 64, which is 3 units per day. So the second equation that we get is 2m plus 4w is equal to 3. How long will it take for 12 men to complete a work which 8 women take 12 days to complete? So from here we can say that if we add the two equations, because the coefficients are interchanged, 1 plus 2 gives us 6m plus 6w is equal to 7. So m plus w is equal to 7 by 6, and 1 minus 2 equation will give us 2m minus 2w is equal to 1. So m minus w is equal to 1 by 2, can be written as 3 by 6. Add these two equations, so 2m comes out to 7 plus 3, 10 by 6, which means m is equal to 5 by 6. Putting that equation, value here or here, we'll get w is equal to 2 by 6. So we get the efficiency of a man and a woman per day. Now, we have to find out the time taken by 12 men. So if the number of days taken is d, we say 12 men working at 5 by 6 units per day for d days have to do the same work as 8 women working at 2 by 6 units per day for 12 days. From here we can get the answer for D. 6 and 6 will cancel. 12 and 12 will cancel. D will be 16 by 5, which is nothing but 5 3s are 15, 1 3, 1 by 5 days becomes the answer, option D. Overall, since equation is involved, therefore I'm saying it might go up to moderate. Conceptually it is easy, but since there is equation involved, I'm saying moderate because the attempt time will also increase to maybe 2 odd minutes. A tank is fitted with pipes, some filling it and the rest draining it. All filling pipes fill at the same rate and all draining pipes drain at the same rate. Suppose the filling pipe fills F liters per minute, the draining pipe drains D liters per minute, or R, sorry. R. D liters per hour is the draining rate, F liters per hour is the filling rate. The empty tank gets completely filled by in 6 hours when 6 filling, 6F and 5 draining minus 5D are on. But this time becomes 60 hours when 5 filling and 6 draining pipes are on. In how many hours will the tank get completely filled? Okay. Now, 6 filling and 5 draining, this takes 6 hours. If we assume that the tank is of 60 liters, we can say that 6 filling and 5 draining fill 60 liters in 6 hours. Therefore, 10 liters per hour. 6 filling pipes will fill 6F per hour. 5 draining pipes will take out 5D per hour. Therefore, net 6F minus 5D should be 10 liters per hour. Similarly, in the second case, 5 filling pipes will fill 5F. 6 draining pipes will remove, therefore minus 6D. This will be the amount of water filled every year. At this rate, it takes 60 hours to fill 60 liters. Therefore, 1 liter per hour. We have two equations in F and D. Add 1 and 2. This is equation 1. This is equation 2. 11F minus 11D will be 11. F minus D is 1 divided by 11. Subtract equation 2 from equation 1. 6F minus F. F minus 5D plus 6D plus D is equal to 9. 10 minus 1. Add these two equations. 2F is equal to D cancel. 9 plus 1, 10. F is equal to 5. And therefore D is equal to 4. 5 minus 4 is equal to 1. So D has to be 4. How many hours will the empty tank get completely filled when one draining pipe, 1D, and 2 filling pipes? So 2F minus 1D is the rate at which the tank is to be filled. 2F means 2 into 5. 1D means 4. 10 minus 4, 6 liters per hour. And we have to fill the tank. Therefore, 60 liters tank filled at 6 liters per hour will take 10 hours to fill in this case. 10 hours becomes the answer, or 10 is what we have to key in. Again, the question as a concept is not difficult, but calculation might take a time and the attempt time might go to about 2.5 minutes. So I'm saying a moderate question. To complete a certain job, P working alone takes twice as long as Q and R together. P takes twice as long as Q and R. So we can say that the efficiency of Q and R, suppose P does P units per day, Q does Q units per day, R does R units per day. We can say the efficiency of Q and R will be twice of P, because for the same time, P is taking double the time than Q and R. So Q plus R is equal to 2 times of P. Whereas Q working alone takes 11 times as long as P and R together. Therefore, the efficiency of P and R will be 11 times of Q. If Q does 1 units, P and R will do 11 units per day, and therefore the time will be 11 times for Q to do the same work as P and R take. If all three of them work, if all the three of them together can complete a job in 4 days, find the time taken by Q. From here, if you subtract equation 1 from 2, Q minus P, R minus R cancel, 2P minus 11Q, 12Q is equal to 3P, P is equal to 4Q. First of all, this is what we get. P is equal to 4Q. If we put that here in the second equation, P is equal to 4Q. So 4Q plus R is equal to 11Q. R will come out to 7Q. And therefore, we can say the three people P, Q, and R. If Q has efficiency Q, P has efficiency 4Q, and R has efficiency 7Q units per day. Now, if all these three work, total work in 4 days that they will do is 4 days. Total work per day is 4Q plus Q plus 7Q, which is 11, 12, 48Q. In how many days will Q alone do this work? Q does Q units per day, so the time taken by Q will be 48Q amount of work to be done by Q alone, and therefore 48 days becomes the answer. Overall level of difficulty, I'd say, is moderate sort of a difficulty, and the equation to be solved are also not very difficult. So about 2 odd minutes to solve the question. Arnav can complete 1/4 of a piece of work in 12th of the time taken by Bhavan to complete the work. 5/12 of the time. If Bhavan does some work in 12 days, Arnav will do 1/4 of this work in 5/12 of 12 days. Arnav will do 1/4 work in 5 days. And therefore, Arnav will do the same work or the entire work in 4 times of this 1/4 work in 5 days. So, entire work in 5 into 4, 20 days. So, the same work that Bhavan does in 12 days, Arnav does in 20 days. If they together can complete a work in 15 days, how many days can Bhavan working alone complete the work? Okay. So we cannot assume this to be answer, but what we can do is, because the number of days taken by Bhavan and uh, Arnav are 12 and 20 number of days, which is in the ratio divided by 3 is to 5, we can say that efficiency of BNA will be in the ratio 5 is to 3. This was an assumed value. Accordingly, we got a proportionate value of it. So number of days has to be in the ratio 3 is to 5. Efficiency will be inverse of that 5 is to 3. Now, if B does 5 units per day and A does 3 units per day, therefore, work that they can do in 15 days together will be total work that they can do is 15 days they have, and one does 5 units per day, the other does 3 units per day. Therefore, 15 into 8, which is 120 units. Then in how many days can Bhavan complete the work alone? So work time taken by Bhavan to do the work alone will be 120 units. Bhavan does 5 units per day and therefore 24 days. 120 by 5, 24 becomes the answer. Again, if we are able to figure out the first line from there, the question is not very difficult, but the first line could be a little confusing. So about moderate level of difficulty and about 2 odd minutes to solve. Overall, if we look at the test, as I said, moderate level, 21 to 24 minutes solving time, 6 questions. The questions I would have chosen would be 1, 3, 6, 7, 8, and 9. Which are these questions? Would have done this proportionality based. Here, there was a chance of confusion happening. Might have left this. Would have done this, again, proportionality based. This was, I think, a good question. So, might have left this in the exam. 5. Would have done this. Actually, the problem here was addition was happening. So could have taken a call in the exam with regard to this, because there is a good chance of missing the number eventually. This I would have done simple ratio and smaller numbers. Would have done this again, simple ratio, small numbers. Now this was easy, similar to the previous one where you forming equations and solving. Takes time, but the answer is always there. I would have done this as well. Again, simple numbers were there. This can be taken a call on because the first line can get a bit confusing. So for me, every single time, 1, 3, 6, 7, 8, 9 will be my attempts. Anything beyond this takes you beyond 95%